Hello everyone. What I have in front of me right here is a little device I've made. Um, Thought of this seeing that we have one of our challenges is to, in the competition table, is to reach up or extend ourselves somehow. Um, and we have the restrictions of an 8x8 starting box cube. So come up with some way of deploying something, and I've come up with this particular device that really isn't specific to any one of the challenges, but could be adapted to a couple of them, I'm sure. So let's go over what I've done here. As you can see, I have a motor mount here. Because I wanted to restrict this to under 8 inches in this direction, and also under 8 inches in at this point, every quarter of an inch really comes into play. So that's why you see my motor angled. There's no other reason other than trying to keep everything pretty much compact. So let's take a little closer look at the drive assembly, because that's that's kind of the heartbeat of any device you make, right? Alright, so as you can see, we have our motor here, and this is actually a horn. It's one of the long horns, and I cut one end of it off to use as an adapter to my motor, because it has the spline attachment for the output shaft. So I cut one of the legs off. You'll recognize like one half of it anyway. I just used my snips, cut it off, filed it to make it a little smoother, and then I located two positions on the horn that I was going to mount one of my bars to here, one of my actuating bars. So that's kind of a neat little idea. Again, everything I'm doing is out of the kit, all available to you. The point you'll want to look at is in my bar here, because I have an axle and potential of everything pivoting about that axle. If you notice, I have a bushing up against my shaft collar. My shaft collar is a locator, but it also keeps this whole section right here as kind of a neat, tidy package. The next portion right here, that's my axle that extends from my horn all the way out the side to my support bracket on this end. And then another shaft collar, another nylon washer in case I have friction issues. I want to reduce those as much as possible. And then I did the same thing with the horn on this side right here. Is I cut one of the legs off, and I replicated what I did on the drive side of the motor. And then you'll notice I have a bushing in my aluminum plate, the flange bushing. The flange of the bushing is acting as a friction reducer on this side, and then a shaft collar on the end that kind of ties this piece together. Like nothing can move linear from the motor. I see that a lot in some of the designs. If you don't take care of that, it's going to definitely become a problem. All right, so let's move back out, because it's probably easier to see. If we look at here are the two arms I've attached to my drive, and they're attached with a shaft that joins the two sides together, because we can't have them just floating out in space like this, right? So we need some constraints, and those constraints are roughly the same distance down here, so we maintain parallelism. And then you'll notice I have these rubber bands attached to these spring pins, and I'll show you that on the other side. You'll see that there are spring pins that go through each one of my parallel arms, and I have a place that are independent from this arm, by the way. So I have a place to hook on my spring. Then it goes around this shaft. These spacers are made up of 1/4 inch nylon washers, so that I can maintain that spacing from side to side. My spring mount for my actuating arm, I took a little piece of the sheet steel or aluminum, and I made this little U-shaped clip as you can see, and slid it over the top, and then I just made two little cuts right in the center of it and just peeled those out with my needle nose pliers, and I made it a place for my elastics to wrap around, because I need tension here, because the whole idea is I want to actuate this so that it extends. So let's see how that actually works. I'm going to hook up my motor. I have everything all set to go, I hope, and turn my power on, turn my controller on, and you'll notice, I'll try to hold it at an angle so you can see it a little bit better. As I actuate my arm, here we go. As I actuate my arm, you'll see that the elastic takes over, and now I have an extended arm right there. So this is all under essentially spring tension, and the spring that I'm using is actually the extension of the rubber band. Another nice feature about this, if you feel you need more spring tension, you can just take this little clip and slide it further away, increasing the stretch on the elastic, which will give you more spring. One last little feature is this little cross member you see right here. This little cross member is meant to tie the two parallel bars to each other so much, but I utilized that and made this little clip that attaches to them. And what that does is it acts as a stop, so when my arm springs forward, I can stop in the vertical. If not, this just can go anywhere it wants. It'll go as far as it can until the elastics come off. So that's what I have for an extending lever arm, and it was actually a lot of fun to make. And like I said, I didn't have any one particular task in mind when I made it, but I know that reaching is an issue, and what I came up with is this, from where my mounts here to the end of my lever assembly is about 7 inches, which is an inch under our allotted space. And when it's fully extended, like you see right here, the distance from this surface right here to the top of our arm is 11 3/4 of an inch. So you can see that you can get quite a bit of height just by making a compact little unit. Now, I left the top open because I'm figuring that you're going to want to attach something to here, whether it's a cutting device or some type of pushing device or something like that. But there's certainly a neat little device that you can somehow incorporate in your strategy. All right. Hope that helps.